Okay, boys and girls. Okay, we may start our lesson today. Okay, I'm Dr. Lo. Boys and girls, last week we stopped at lesson number 6, page number 12. We finished page 12. Today we are going to study about centripetal force. Okay, today we are going to the centripetal force. Okay, boys and girls, centripetal force actually is a force that causing object moving in circular motion. So once you saw the question talking about circular circle, or you saw it at the corner of the rope bending or what, actually is related with today's topic lah. Okay, so centripetal force, for example, this one is very simple demonstration about centripetal force. Okay, so you will find that the object actually there is a string holding it. Okay, so the object can move in circular path, circular motion. So what causing the object can be moved in this way? Okay, so this is what we are going to learn today. Okay, so we come back to our lesson here. Okay, when object moving in circle, so at here find the keyword. Circle is under this topic. Although the speed is constant, but direction, can you see that this direction is supposedly it's going straight, going straight. But we found out that the direction they moving in circle, that means that the direction keep on changing. It's not moving in a straight line. It's not moving in a straight line. It will keep on changing. That's why it form a circular motion. Okay, so at here, the direction is continuous changing. Okay, starting of the chapter 2, we have learned the difference between speed and velocity. Am I right? Okay, speed is what? Speed is the scalar quantity, which is only need to consider the magnitude. I don't care about the direction. Okay, that is called speed. But when we're talking about velocity, this is a vector quantity, which means that right now we not only consider magnitude, but we also need to consider direction. Okay, so velocity is having to consider direction. So look at here. Although the question said that speed is constant, direction change. So your velocity should be changed also. It cannot be constant anymore because it involving with direction. Now the direction changing, so your velocity should be changing also. So we write down, speed is constant, direction change, velocity will change. Okay, change in velocity. Velocity is changing. For example, changing v minus u. Okay. So previously we learned, okay, acceleration is v minus u over t. So what is the definition for the acceleration? We say rate of change of velocity. This one, rate of change of velocity. So at here, I want to tell you that if your velocity is changing, that means that the object is accelerating all the time. Accelerating. Okay, because here, dear, v minus u, yes, we got some changes for the velocity, so object will accelerate. Okay, object will accelerate. Okay, next. What causing the object to accelerate? Why it accelerate? Accelerate meaning speed up, okay? But at here, accelerate is because direction changes, okay? So at here, the force that causing the object will moving in circular motion and causing this acceleration is, we call it as centripetal force. Centripetal force. This is the topic that we want to learn today, called centripetal force. Okay, so we look at this. The car, okay, at the roundabout, it can turn, okay, move in circular path. The car at the roundabout move in circular path. Okay, supposedly the car will travel straight, but at the end, there is a force pulling towards to the center. There is a force called centripetal force acting towards to the center, causing it to change direction, change direction, change direction, keep on changing direction. Okay, so the acceleration, this is, maybe we can label here the centripetal force. This is our centripetal force. I put a small c to represent centripetal force. Okay, this direction is pointing towards to the center. it will cause the object moving in a circular path. Okay, then after that, the acceleration, we say that object accelerate. What direction object accelerate? Actually, is same direction as your resultant force, which is A here. Okay, so at here, acceleration, number 5, acceleration is perpendicular to the direction of travel, or I can say that direction of travel is motion, or we say velocity, okay, the velocity direction. So the object actually is here. This is the velocity, or I say this is direction of travel or motion, okay? So can you see that they are 90 degree? Actually, all the object they're trying to move in a forward way, okay, in a straight line, go straight, okay, but at the end, because there is some force changing it, make some change, okay, on the object. That's why the object will keep on changing direction. Okay, what force causing the object moving in circular path? Answer is centripetal force. Okay, centripetal force is the resultant force that causing object moving in circular path. Okay, last week we already learned what is what resultant force, right? We got talking about resultant force. Resultant force is many force, then at the end we find a single force. So in this system, there is a resultant force called centripetal force. Okay, so at here, centripetal force will be affecting by this few factor. Okay, it will increase. That means that we need more inward force. Okay, we need more force pulling it towards to the center if your mass actually is higher, increases. Okay, so if let's say the car is heavy car, so we need more centripetal force to holding it and change its direction. Okay, then after that, velocity. Actually, for this part, centripetal force, we can using formula helping us to understand the situation. But actually, this formula, we will not using, okay, no calculation in this centripetal force chapter. Okay, but with this formula, we can helping us to understand. Okay, so you look at this. Centripetal force, higher centripetal force. When your mass is higher, larger mass, so I need more centripetal force to make it change direction and moving in circular path. Okay, V here, mv square, V velocity. If your velocity increases, you will also need a higher centripetal force to hold it. Okay, okay, this one, what happened to your radius? If we want a higher centripetal force, so your radius should be increase or decrease the radius. So if your mathematics are 1 over a small value and 1 over a big value, this one small value, for example, maybe you can using, let's say we put some example only. Small value 0.1, okay, or we say 1. Then this one we divided by big value 1000. So you will find that this is 0.001, right? This is 1, right? So if this value is more, 1 over this formula divided by a small value, actually your FC actually is a higher FC. Higher force is needed. Okay, so at here we can say that the radius of the circles decreases. Okay, so if you using formula helping you to understand, it will be much more easier. Okay, but this formula we are not going to use to do any calculation. Okay, so here the formula divided by something. This bottom part, if the value is more, small value, then the FC resultant force will be higher. Okay, is it okay until here? So few things I need you to know. Where is the direction of your centripetal force? Centripetal force always towards to the center. Okay, where is the direction of your motion? This is the direction of your motion. It will always perpendicular to your centripetal force. Where is your acceleration? Acceleration same direction as our resultant force. Basically, the most important part is here lah. Okay? Any question? Can you give me some response so that we can know that we can proceed to the page 14? Okay, so we goes to your page 14. What providing centripetal force? Teacher, what causing there is a force pulling inwards? Okay, centripetal force is a general name. It's a general name. Okay, for example, we holding the string. This is a string. Okay, so this is the ball, like the video that I show you just now. They're holding the string and then the ball, and then we swing. Okay, make it in the circular motion. So what causing this centripetal force? This centripetal force is due to the force in the string. Force in the string, we call it as tension. Tension. My boys and girls right now. Tension in string. Okay, this centripetal force is the tension in the string. Okay, now one more point I want to tell you. All the time, the ball trying to go straight. At any position, they were trying to go straight. Okay, they were trying to go straight, but every time there will be changes the direction by the centripetal force. Okay, you can draw a few more. All these are our velocity direction. We're trying to go straight, but because centripetal force is pulling, so they will change direction, change. At the end, circular motion. Okay, but what if, okay, the centripetal force suddenly disappear? For example, the string break, suddenly break. Okay, if at this moment, what's going on with your object? Okay, the ball at here, suddenly there is no more centripetal force acting towards to the center. Suddenly no more this force. Where is the object going? So object, it will continue its motion, which is the v direction that we draw just now. Okay, so at here, if the string break, no centripetal force is provided, the ball will be continue travel in a straight line due to, okay, we write it down, due to called inertia. What is inertia? Actually, this is Newton first law. Okay, Newton first law is saying that object at rest, it will keep on at rest, keep. Okay, if object moving with constant speed or constant velocity, it will keep this motion. Okay, so for example, boys and girls, you imagine you sit inside the car. Suddenly we are driving the car. Suddenly there is a emergency brake. What do you think of your body? Okay, what happened to your body? So your body will move forward. Am I right? Suddenly emergency brake. So you move forward. Why you move forward? Because inertia. Why inertia? Because when car is moving, our body also got the inertia to tends to moving forward. Suddenly emergency brake, our body we still have the inertia trying to move forward. So at the end, our body move forward due to the emergency brake. This is called inertia. Okay, so for the ball also the same. Actually, it's trying to move forward, move forward, move forward. But because every time there is a centripetal force change the direction. That's why make it changes the direction until we move in circular path. But once at a moment, there is no more centripetal force holding it. So what's happened to the ball? The ball will have its inertia trying to move in a straight line. Okay, so you are trying to follow the direction of motion, direction of travel, or we say velocity direction. Okay, so next, satellite. Okay, why satellite can be moved in a circular path around the earth? Actually, there is a centripetal force. What caused this centripetal force? We call it as gravitational pull. Okay, gravity, yeah. Okay, gravity pulling, so it will make the satellite keep on changing direction, change. At the end, it's around our earth in circular motion. Okay, we goes to your page number 15. Until here, okay or not? Can we go to page 15? Give me a response. Okay. Megan say okay. Hui Tong say okay. Okay, boys and girls, we go to page 15. Okay, planets around the sun actually is also the same. How come the planet we can have in order, okay, in circular motion? So this one is because the sun got gravity pulling us, okay? So sun's gravitational pull produce the centripetal force, okay? Whatever this planet towards to the center, this is our centripetal force, okay? Supposedly it's trying to move forward like this. This is the velocity, direction of travel, but it will not go straight is because centripetal force keep on changing it, okay, changing the direction. Okay, for the electrons around the nucleus, this is because of the electrostatic force. Okay, so electron, there is a centripetal force towards to the center. If suddenly one day, without this centripetal force, where is the electron going? It will go to this direction. Okay, it will go to this direction. Okay, so number 5, vehicle. Okay, we move in the circular motion roundabout. Maybe you haven't got the license yet lah, okay? We driving, we want to change our direction at the roundabout so that we can go in a circular motion. Okay, it's not going straight. Going straight is easy, okay? But when we goes to the roundabout, we need to keep on changing the direction. How we make the car able to change direction? We're providing the centripetal force. Where is the centripetal force of the car come from? Actually, answer is friction. We apply the brake. Okay, we apply the brake. So the friction between, there is a friction. The friction providing the centripetal force so that we can keep on changing direction and move in circular motion. Okay, friction between the tires and the road. Having a look overallly, this is the general case, okay, why it producing the centripetal force, okay. But for the car, this one quite important, we have to know this is because of the friction. Okay, if okay, we are trying to practice the past year question to test our understanding. Is it okay, dear? There is a button here to react and show me your reaction so that I know that we can proceed to the next page. Okay, So boys and girls comes to this past year question. Okay, here. Satellite orbit the Earth above the atmosphere at a constant speed. Diagram show the satellite at one point in its circular orbit around the Earth. Which label arrow show the directions of the resultant force, which is what we say centripetal force? On the satellite at this position, where is your centripetal force? Direction A, B, C, or D? Okay, type your answer in the chat box. To the Newton scholar, the profile Dr. Low is my iPad. I won't able to read the chat, your message. Okay, we don't give me the answer. Answer, Licious. Here, direction of resultant force for it to move in circular. Is there any? Okay, here, boys and girls, highlight circular orbit. Where is this resultant force? We come back here, Licious. Centripetal force, always acting to the center. Center. Okay, so boys and girls here, your answer should be donkey. I want to extra ask you a question. If let's say there is no gravity of Earth, can you tell me where is the satellite will go? If there is suddenly our Earth, there is no more gravity pulling the satellite, where is the direction of the satellite will go? Can you help me? No, Crystal, no. It will move in a straight line in a motion. Where? A, B, C, D. A, B, C, D. So what do you think? Where it go? But Hui Tong answered correctly. How about others? Megan, no. Megan, no. Right, dear? Crystal, Megan, try again. Licious? Licious correct. Let me have a look. Crystal correct already. Megan correct. Okay, dear. Remember, what should we do? This is the direction of the satellite moving. So that means that at every single point at here, they were trying moving in a straight line like this. So at this position, it will trying to go straight at this direction. It will always 90 degree to your centripetal force. So at here, your answer should be C. If this is answer D, if let's say there is no gravity pulling on the satellite anymore, where is the direction of the satellite will go? Answer is C. Why not teacher answer A also perpendicular to the resultant force? What teacher? But you have to be careful of the direction of the circular. So they're showing in this direction. That means that it's trying to move at here, at here, at here direction. Okay, of course, we come back to the question. This question, centripetal force is D. But just now, the second question is, I'm asking if there is no gravity, where is the satellite goes? Okay, the satellite will go to C direction. It's not B, dear. It's not B. We come back to here. See, this is the direction of motion, which is 90 degree to it. Okay, if the string is black, no more centripetal force. Where is the ball going? It will continue to the V. Why? You look at this direction of the motion. Circular motion, this circular motion. Okay, where is this going? Goes to this direction, V. Okay, so we go to the next question. A satellite orbit the Earth at a constant speed in a circular motion. Again, find the keyword. This question talking about circular orbit. Which statement is correct? Okay, boys and girls, read it and then tell me your answer in the chat box. Correct, Hui Tong. How about others? How about others? Is it B? Yes. Answer is B. Okay, answer is B. We look at the A, B, C, D and see what's going on. Okay, resultant force is 0. Is it resultant force is 0? No, it's not 0. Not 0. Why? Our resultant force actually is the centripetal force that we mentioned. We have resultant force. The resultant force called centripetal force. So we got resultant force. It's not 0. We got force. Okay, the resultant force on the satellite is away from the Earth. You means that this one away from our Earth. Is it this? B? This is our centripetal force? No, it should not be C, away. Okay, so this one is also wrong. Away is wrong. Towards, yes, correct. Towards to the center. Our center is our Earth center. Okay, resultant force is same in the direction of a motion. They say that like this, circular. Then this one is Earth, let's say. Let's say the satellite is here and moving in this V. This is the direction of V. They say that your resultant force also in this direction, same as the direction of motion. Is it correct? My answer is no. Direction of motion is the velocity direction. So this one is wrong. No, no, no. Where is your resultant force, dear? Resultant force always pointing towards to your center. So this one also wrong. Is in the direction. No, it's not in the direction. So B, answer is B. Okay? Is it okay? Can we proceed to the next question, dear? Okay. Next. We know that in moving in circular path, object will accelerate. Accelerate is because velocity change. Why velocity change? It's because direction change. So which statement about acceleration at the point P is correct? So read it. What is about the acceleration is correct? Hmm. Let me check other students' answer. Hui-Tong, no. Hui-Tong, no. Refer to the notes there. Megan also no. Dear, refer to your notes. Crystal also no. Why, dear? No. Xuan and Samsung. Yes, you are right. Samsung, you may change your name. If not, I keep on calling you Samsung. It's very weird. Okay, boys, where is your acceleration? Refer to your notes just now. Where is your acceleration? Acceleration. It will always perpendicular to the direction of the travel. So this is direction of travel. It will perpendicular. Actually, acceleration same direction as our resultant force. So it will also pointing towards to the center. Okay, so boys and girls here, it should be pointing towards to the center, which is C. Which is C. Is it okay, dear? Okay, Teresa. Okay. Crystal. Okay. Dear, we look at this. This is 2020 MCO question. A model car traveling at constant speed on a flat circular track. Keyword circular. That's why we understand this is under this topic. Okay, the speed of the car is 0.3. Write down V. Speed symbol is V. In one complete revolutions around the track, the car travel 3.9. This is the distance, how far it travel. We write S. Calculate the time. T. Write down T. Calculate the time taken for the car to complete one revolution around the track. So at here, we need to think what formula we can relate this. Speed, distance, and time. Okay, we travel 3.9 meter. Then our speed is 0.3. Then how long the time we need? So V equals to S over T. 0.3 equals to the 3.9 divided by T. So your T, press your calculator. Okay, do not wait for my answer. Press your calculator. What is how many seconds? Okay. Okay, B, on figure 3.1, this is the one that I want to emphasize under this topic. Okay, draw and label the letter F. An arrow to show the resultant force acting on the car. The car can be moved in at the roundabout there. It's because there is a resultant force pointing. Okay, resultant force pointing to what? Okay, thank you, Krista. Give us the answer. 13 seconds. Okay. Then can you draw the resultant force acting on the car? Where is the direction of your resultant force? It will always pointing towards to your center. Okay, can I score the mark? What do you think? Can I score the 1 mark? Is it 1 mark here? Yes. Can I score 1 mark there? What do you think? I already draw the direction of the resultant force. Okay, can I score the 1 mark here in the exam? My answer is no. Why no? Read the question carefully. Draw and label with the letter F. Teacher, can I label like this? My answer is no. It already mentioned F. So you don't label other things. You don't label centripetal force FC. No. Okay, label F. That's all. Settle the problem. Okay, is it okay, dear? Okay, Teresa say yes. Okay, Crystal, yes. Okay, boys and girls, we goes to C. C here. Speed of the car increases. Okay, boys and girls, if your speed of the car increases, you imagine you're driving very fast. You want to turn, change direction. The resultant force actually need higher or lower from this sentence. Okay, car moving in very fast speed. Suddenly I need to turn it. Okay, I need to change direction and moving in circular path. My centripetal force actually need higher or lower? What do you think, dear? Any of you can answer me? My centripetal force actually become higher. The more or less centripetal force in neither. Okay, the centripetal force that I need actually is more or less, become more or less. Thank you, Megan. More centripetal force is needed. If you want to keep it in circular motion, when your car is very high speed, then you have to think. You need more centripetal force to hold it and make it changes direction. Here, the question said that the speed increase, but unlucky, the car does not able to stay on track. That means that it doesn't able to continue in a circular motion. Okay, in terms of force, why it cannot stay? Just now we already mentioned, if the speed increase, we need more centripetal force. If we didn't have enough of centripetal force, what's going on? The car, it cannot continue in circular motion, not enough to hold it and not enough to make it in circular path. Okay, so at here, in terms of force, why the car does not stay? It's because the centripetal force that we have is insufficient. Okay, it's insufficient. That's why the car cannot stay on the track. So we write down, okay, the resultant force, or we say centripetal force, insufficient at higher speed. Okay, at higher speed we need more, but what we have is not enough to support it. Okay, what we have is not enough. Okay, second one, 0.32. Draw and label an arrow with the letter S to show the direction of motion of the car as it leaves the track at point P. Okay, at point P, it's not enough to hold anymore. Where is your car going? Where is your car going? Okay, I give you few options. Okay, A, B, C, okay, A, B, C, enough. A, B, C. If let's say it's not enough to hold, okay, where is your car going? So let me have a look. Correct. Okay, Hui Tong, Megan, Licious, Teresa. Oh, correct. So boys and girls, if let's say there is not enough of centripetal force holding it, that means at this position, the car, it will go straight. Okay, it will follow the direction of motion. So for this question, okay, it will go to this direction and we need to label S. So here we label S. Okay. Okay, normally why I draw in this direction, I assume this is the head part of the car. So it moving in this direction, okay? So at here, I goes to this direction, so I assume this is the direction. If we cannot differentiate, if let's say this is just a ball, a ball here, a ball. So if they didn't tell us the direction of the circular path, actually we can draw to this or draw to this, doesn't matter. You get what I mean, dear? Okay, here again, if let's say it's not a car, it's just a ball. And then some more, they didn't tell us that where is the ball direction, your circular path is going to which direction, clockwise or anti-clockwise. If the question doesn't mention, so once we lost the centripetal force, you can draw, move forward, or you want to draw at this direction, no problem. But if let's say they already told you this is the direction of motion, okay, then the only answer is this. Okay, this is the answer. When there is not enough centripetal force, then it will go to this direction. Follow what? Follow this. Follow the direction of circular path. But if let's say they didn't tell you the circular path, both sides we are accepted. Okay, both sides we are accepted. So here you see we have to pay attention on the direction. So it moving clockwise. That's why if let's say there is no more gravity, so it should go to C direction because of this. Is that clear, dear? If you got question, you may ask in the chat box. If you're shy, you can private message Newton Scholar chat box, okay? If no question, then we will go to your lesson number 7. We learn about Newton's second law. Just now we talked about Newton's first law, inertia. Object at rest, keep on at rest. Object moving, it will keep on moving. One more. The door, let's say we want to close the door. Actually, we just push a little bit, then we can go away. The door will automatically close it. Not because of the spring. Let's say there is no spring or whatever to hold. So we just push, the door will continue close it. Continue. Why continue? Inertia. Inertia, it get moving direction, it get the what we say energy to move forward. Then at the end, because of inertia, it will trying to continue to move forward. So at the end, the door will be closed. Okay, that is inertia. So we are already talking about Newton's first law. Why I didn't have any lesson talking in detail about Newton's first law? Because this Newton's first law not really in the syllabus. But sometimes when we answer your IG, it will suddenly appears again. Why is it like that? Because inertia. So I still need to teach you about a little bit knowledge about inertia lah, although there is no worksheet talking about that. Okay, so now we already finished talking Newton's first law. We're talking about centripetal force. Now it goes to the Newton's second law. Newton's second law. Lesson number 7. Can we start a new lesson, dear? Is it okay? Okay. Hui Tong, okay. Teresa, okay. Okay. Crystal, okay. Megan, okay. Thank you. Okay. Newton's second law states that if there is an external force acting on the object, the acceleration object is directly, write down, directly proportional to the magnitude of force. So what does it mean? Acceleration directly proportional to the force. Meaning that your force increase, your acceleration will increase. Okay, now I draw 2 objects here. Let's say this one I push with 10 Newton. Your trolley, you go to the shopping mall, you push the trolley. Then this one I push with 50 Newton. Okay, A and B. Can you tell me which one will move acceleration, meaning the speed up? Which one can be higher acceleration? 10 Newton or 50 Newton? Which one will have a higher acceleration? A or B? 10 Newton will speed up faster? 10 Newton will speed up faster? I push using a small force, push it. Will you think that it can speed up easily? Or actually, I push harder, it will speed up easily? What do you think? 10 Newton is the force that we apply. Then 50 Newton, I push harder. So what do you think? Which one actually the object will speed up faster? Licious, what do you think? B, because there is more force, yes. Okay, it should be 50 Newton. If 50 Newton we push harder, actually this one, it will accelerate. Okay, it will accelerate, higher acceleration. Wait, higher acceleration. So can you see that when the force increase, we can make object speed up easily. Okay, same mass. This is 1 kg, this one also 1 kg. But I push further, I push harder. Okay, with the greater force, I push harder. So at the end, your force increase, your acceleration will also increase. It will, their relationship called directly proportional. Directly proportional actually is a straight line passing through origin. So we draw it out. Directly proportional, we got two features. One is straight line. Another one, okay, pass through origin. Straight line, pass through origin. When there is no force, will your object accelerate? When force is zero, of course, object cannot move. So it won't have acceleration value. So we start from zero. Okay, so at here we say A is directly proportional to the F. Okay, force increase, A also increase. Or you can think this is the small kid push. This is adult push. Adult, of course, have a greater force. So which object actually can be accelerate, speed up easily? Answer is the adult. Adult with greater force can be speed up easily. Okay, until here, okay, dear? Okay, so look at here. Acceleration is directly proportional to the force, and it will be inversely proportional. We write down here inversely proportional to the mass. It will inversely proportional to the mass. What does it mean? Okay, I'm going to show you. Done writing? Okay, here I write down inversely proportional. Okay, inversely proportional meaning that when your mass increase, your acceleration actually will decrease. So example again, you got something to push. Let's say this one is 1 kg. You push with your adult 50 Newton. Okay, another one is bigger object, which is 10 kg. Okay, you go to the shopping mall. You buy the whatever you want, the tissue, the rice or whatever, okay? Starting the trolley is empty. You push it, okay? Then after that, you add in the liquid detergent, the rice, whatever, okay? Toothbrush, okay? You add in a lot of things inside your trolley. Suddenly your trolley mass increases. It's become very heavy. So now, boys and girls, I want to ask you A and B. Which one acceleration will be greater? Which one easily to accelerate, speed up? The heavy one or actually the lighter one? Which one easily to accelerate? Let me check. Okay, Hui-Tong, Megan, and also Teresa. Yes, the lighter one, dear. Here, I want to take notes at here. When your mass is small, you apply same amount of force, you are easily to make it accelerate. The empty trolley is so easily for you to speed up. But if this is become very heavy, you're trying to push with the same force, it move very slow. So at here, can you see that this relationship? M decrease, A will increase. Or here, M increase, A will become decreases. What is their relationship? This is called inversely proportional. Inverse. How was the graph showing? It was showing like this. Mass increase, let's say here is 10 kg. Acceleration is very small value. So let's say 1 kg. Acceleration is big. So the curve, actually the graph will be a curve like this. Is that clear? Okay. How about others? Teresa saying yes. How about others? Okay. If okay, we are going to the page number 2, dear. Page number 2. Okay, let's go. Because of just now these two graphs, we form a formula. Okay? So at here, you see, we get F equals to ma. So if your force increase, your acceleration will increase. Do you agree? Okay, F increase, acceleration will increase. Okay, if your mass increase, your acceleration will decrease. If you're using a mathematic way to understand, if let's say my force that I apply is 50 Newton, okay, the mass is 10 kg. So my acceleration will become 5, right? But if let's say my mass is only 1 kg, that means that my acceleration can become 50 meter per second square. Can you see? If my mass is small, my acceleration becomes bigger. If my mass is big, my acceleration becomes smaller. While we're still applying the same force. This example is to want to tell you that relationship between M and A. Okay? They are side by side like this. So their relationship will be inversely proportional. Okay? Is it okay for this? Net force, the force that we use at here, F equals to ma. But here, I will emphasize this is called net force, or we say resultant force. Unit is in Newton, but if we want to base on F equals to ma to get the unit also can. M is in kg, A is in meter per second square. Kg, meter per second square. Or we just say that is Newton. Mass in kg, A is meter per second square. Is that clear? Any question you want to ask me? If no question, then we are going to try with the past year question and test our understanding. Is it okay? Okay. So boys and girls, we go to this. What is the acceleration? The mass, we write down m 1200. Okay. A. Then there is a force. So we write down F equals to ma. Your mass is 1200. Your A you want to find. What is your resultant force, dear? What is your resultant force? Is it 4000? Is it 1000? What is your resultant force? Still remember? Last few lessons, we talked about resultant force. I give you a few examples asking you to find resultant force. So boys and girls, can you tell me what is your resultant force? Type in the chat box, tell me. We don't say 3000. Where we get the 3000? Teresa said 3000. Where we get this 3000? Okay, boys and girls, 3000. Yes, 4000 minus 1000. This is the correct answer. Still remember, there is a box here. Let's say this one is 4000 Newton. Here is 1000 Newton. So what is your resultant force? You should get 3000 Newton towards to the right. Follow the bigger force. So at here, this one should be 4000 minus 1000. So we get 3000 equals to 12008. So count what is your A. That's all. So this question is want to tell you the force is not driving force, not the frictional force, is resultant force. F equals to ma. This is resultant force. Okay. If you press your calculator, you should get C. Answer is C. If no question, we try with question number 2. Is it okay, dear? Okay, here. A box with 4.0 kg, write down M. We pull, okay? We pull by a force. Constant frictional force at here is 2 Newton. Okay, the speed of the box increases from meaning this is starting. Starting velocity we say is u. To this, that means this is final velocity. In the time 2 seconds. Teacher, how can I count? What formula we can use? We got F, we got M, then we got this part. Actually, we can using what we learned today. F equals to MA. But we don't have A. Do you guys able to find A first? How to find A? A equals to V minus U over T. This is acceleration formula. Yes, Teresa, V minus U over T. Yes, correct. So boys and girls, can you try and then tell me what is your answer for your force? Do it right now. They don't give you A directly. We can count it up. Megan, no, Megan. Resultant force. F is not resultant force. Almost there, Megan. Try one more time. No, Teresa. Resultant force part. You finding F. F is not resultant force. Teresa and Megan, try again. How you find resultant force? You almost there, but not yet to the final step. Any others? No? Give you some hints, huh? There is a force pull. There is a frictional force. Can you see that? They are opposite direction. Okay, so what is your resultant force? It should be using F minus 2. Agree? Continue. Correct, Megan? No, correct. How about others? Already finished writing. Okay, Licious, no? Crystal, yes. Okay, so at here, 4 plus 2 actually is 6 Newton. Okay, here, the common mistake is because this part. I think you will just put F here. Then you using 4, then this one finding A should be no problem for you. That's why you choose B as 4 Newton. But you don't forget, overallly, we draw the diagram out. They say that they got frictional force. So resultant force should be the force that we provided to pull minus the frictional force. Is it okay? Correct. Okay, then we goes to your page number 3. Then we goes to your page number 3. Okay, that is all showing you the horizontal force acting on the car. Which statement is correct? Read it and then tell me. Megan, correct. How about others? Emily, today I didn't saw an Emily. What is your answer, dear? What is your answer? Kristen, no. Teresa, yes. Okay, boys and girls, answer is speeding up. Speeding up means what? Accelerate. So we look at this. Net force equals to MA. What is our net force? 2000 minus 800 minus 500. That means that you got the resultant force of 2000 minus 800 minus 500, then MA. Am I right? That means that your net force is not zero. Your net force is not zero. Do you guys still remember? The few lessons ago, we're talking about the force. We got two. One is called balance force. Another one we call it as unbalanced. Okay, if balance force, for example, here 10 Newton, here also 10 Newton. Okay, so object at rest or object in constant speed. Okay, so if unbalanced, for example, here 20 Newton, here is 8 Newton. So you will find that your net force is not zero. Just now balance is net force is zero. Okay, if like this, we got few possible motion, which is maybe object accelerate, maybe object decelerate, or maybe object is moving in circular, just now, circular path. We need changes direction, so we got resultant force. Okay, unbalanced force is resultant force, we got resultant force. So in this case, C confirm wrong. Because we got resultant force, so C impossible. Okay, why not the car is slowing down? Slowing down, you see the resultant force that we get, actually our resultant force is in this direction. We get our resultant force is same as our motion. Our resultant force direction is same as our motion. So we will speed up. If let's say slow down is what the case, okay? If let's say this is the car, we got forward 2000. So we got the 800, we got the 500 Newton for the friction, but suddenly there is a strong wind blowing against our motion. Strong wind. So suddenly the strong wind, it become like, let me have a look, maybe 1,600, okay? Suddenly it become 1,600 Newton, strong wind. The air resistance higher. So strong wind blowing against our motion. At the end, you look at the resultant force that we have. The left hand side actually is 1,600 plus 500. We get 2,100 Newton. But our forward motion direction, the force is only 2,000. So what is our resultant force? Our resultant force will be oppose our motion. Our resultant force at here is 100 Newton. Oppose our motion, it will cause our car to slow down. So we driving, suddenly strong wind, we slow down, but we never moving backwards. If the resultant force in the same direction of our car motion, then it will accelerate. If your resultant force against our motion, then the car will slow down. If the object moving with constant speed, that means no resultant force, it is balanced. Okay, is that clear, boys and girls? How about others? Do you able to follow me? Yes, Megan? Okay, Shuan? Okay, so at here we go to the next question. The diagram shows four identical objects. Each object is acting on by only the three forces shown. Which object will accelerate to the right with smallest acceleration? Now, boys and girls, answer me in the chat box. A, B, C, D. Which one accelerate to the right with the smallest acceleration? Kristen, no. Kristen, no. Accelerate to the right. How about others? Yes, Teresa, yes. Krista, yes. Okay. Keyword must be to the right. Must be accelerate. Okay, so smallest acceleration. Okay, boys and girls, look at here, this case. What is the resultant force? My resultant force is 50 minus 10, so it's 40 lah. What direction? To the left. So that means this object will moving in this direction. It will move to the left. So A confirm wrong because we want to the right. So A confirm wrong, okay? So imagine your friends, this is the object, your friends push with 10 Newton, you and another two friends push harder. So the object will going to the left, follow the bigger force. Okay, next here. Resultant force is 10, 20, 30. Then another one also 30. What is your resultant force? 0. If your resultant force is 0, your acceleration will be 0 also. Why? Because it is balance force. Balance force, we got two cases. One is maybe object at rest, or another one object at constant speed. It don't accelerate, dear. It don't accelerate. Accelerate meaning speed up. It don't. It doesn't happen. Okay, it will maybe at rest or maybe it's moving with constant speed. Okay, see? Your resultant force will be 40 minus 20, so it will be 20 Newton. Okay, to the right. Okay, so it follow to the right. But is it the smallest one? Then we're having a look. This one also wrong already. Okay, D. Resultant force is 60 Newton to the right. So smallest A, which one? 20 Newton and 60 Newton. Which one having a small A? Okay, F equals to MA. You want a small a. This one small. So your net force actually should be small also. Answer will be C. Is it okay? Okay. How about others? Hui-Tong, okay. Megan, okay. Xuan, do you able to follow us? Crystal, yes. Xuan, okay. Like boys and girls, we goes to here. Oh, this question a little bit tough. Okay, but it's okay. We do step by step and then you think, drag force. What is drag force? Drag force is oppose your motion, always oppose your motion. It can be air resistant. Okay, increases with speed. Okay, maybe I can draw my car. Cute car. Okay, my car here. There is a drag force. And then they tell you drag force will increases with the speed. Yes, of course. Last week we learned about terminal velocity. We also saying that when we accelerate, air resistance will start to increase. Okay, at 20 meter per second, total drag force is 400 Newton. So here 400 Newton at 20 meter per second. The mass is 1,200 kg. The drive force is constant, which is 700 Newton. Okay, can you tell me and calculate what is your acceleration? And then what happened to your acceleration? Combine the last week knowledge and today what you learned. Can you choose the correct answer? Remember, the drag force will increases. When you speed up, it will increases. So from time to time, what's going on with your drag force and what's going on with your acceleration? Yes, correct, Teresa. How about others? Resultant force. So we're using 700 minus 400. We get 300 equals to 1,208. Your acceleration should be 0.25 meter per second square. So your only answer is A or B only. A or B only. So now we have to think, acceleration will increase or decrease as time passes. Accelerate means what? Speed up. Am I right? Accelerate meaning speeding up. When you speed up, what's going on? Drag increase. If drag increase, for example, right now, the drag become like 600, okay? This one drag increase. So it becomes 600 Newton. If let's say from time to time, when we speed up, the air resistance also increases. It becomes 600 Newton right now. What is your resultant force? 700 minus 600, you only got 100, 100 at here. So 300 divided by 1,200, you get 0.25. If here only 100 divided by 1,200, do you think that your A is increase or decrease? When your resultant force decreases, okay, here, drag force will increase. So your resultant force will decrease. Your acceleration will F equals to ma, force decrease, resultant force decrease. So your acceleration will decrease. So answer should be A. Is it okay, dear? Teacher, I'm confused about the acceleration increase or decrease. Acceleration increase or acceleration decrease actually is still speeding up. It still increase the speed. But the first one, acceleration increase, meaning that it's increasing the speed very fast, in a very fast rate. Then after that, it's still increasing, but slow down. Last week we learned about terminal velocity. Let me find again, see whether can find or not. Terminal velocity. Let me have a look. This one. Okay, Teresa, we're having a look of this.
Maggie, guarantee menjadi.
When a skydiver jumps out of a plane at 3,000 meters, her speed goes...
Okay, observe when it jump down, so it will accelerate. Accelerate meaning speed up. Okay, starting accelerate very fast, but after that, what's going on with your acceleration when starting having an air resistance?
through some big changes.
Speed up. You see, speed up very fast. Okay, because just now air resistance very small, but right now it's still increasing. Okay, here I come back to here. Starting increasing speed very fast. Accelerate. But after that, acceleration decreases. It's still speeding up, but slow down the increasing speed. 55, 54, 54, 55. Then maintain the velocity. Okay? So actually, Teresa, acceleration increase or decrease, actually they still increasing the speed. But accelerate increases, that means that it very, very fast than previously. Acceleration decreases, that means that it increasing the speed, but not that fast. From 48, then it become, take longer time, become 49, 50, 51, 52, 54, 55, something like that. Is it okay? Okay, so can we go to your page, next page, page 4? Number 6, question number 6. Okay, can you tell me what is a magnitude? Magnitude means value, dear. Magnitude, that means value. Value and direction. Okay, what is the magnitude of your resultant force? What is the value for your resultant force and what is the direction? Any of you? This one is easy question, dear. Anybody here? To the left. Okay, Teresa, I will encourage you to write your final answer in IG. 2 significant figure or 3 significant figure. So if you write 2 Newton, actually a bit dangerous. I will write 2.0 Newton. See? 1, 2, 2 significant figure. Okay, direction is to the left, correct. Can you calculate the acceleration of the object? Okay, do your calculation right now, dear. Y10, yes, Y10, correct. Do calculation for your acceleration. Nothing to waste for so long, dear. Answer yes, Teresa, 2 significant figure and your unit. Return 2 significant figure to the and the unit. Net force is 2, M is 0.5, A is 4.0 meter per second square. 4.0 meter per second square. Make it 2 significant figure. Yes, correct. Okay, yes, correct. We go to the next question. Okay, a bus is traveling along a straight road. The bus and driver, bus plus driver is already having the combined mass, 16,000 when there is no passenger. Now, the bus has 73 passenger. Average mass for each passenger is 65 kg. Can you find the total mass right now? Find your total mass. Okay, we don't make it 2 significant figure. Make it 2 significant figure, Teresa. In IG, if you refer to the answer scheme, they always give the final answer in two significant figures. So can you make it in two significant figure? No. Two significant figure is, okay, boys and girls, this one total mass. Is the mass for the bus plus driver, which is 16,000, plus the passenger 73. Then each of them is 65. Yes, Xuan, correct. So if let's say you calculate and you get 20745 kg, actually it's 1, 2, 3, 4, 5, 5 significant figure. So we make it two significant figure is actually here. 1, 2. So because 7 we can go in. So you count 21000 kg. This is two significant figure. The behind 0 is not considered. Okay, so at here your answer should be 21000 kg. Okay, with this mass, they tell you that the fully loaded bus accelerate uniformly from rest. Write down U equals to 0. Starting from that means starting. To the speed, so this one write down V. The time taken is 20 seconds. Can you calculate resultant force? Resultant force equals to MA. What is your resultant force? They don't give you an A, so you have to calculate the A. And how about others? So this one I can use 21000. A is V minus U over T. So I using 14 minus 0 divided by 20. My resultant force for me, I make two significant figure. Can be 2 to 3. So my answer is 15,000 Newton. I make it two significant figure, but if you count 14700 also never mind. It's three significant figure. Is that clear, dear? Okay, you might be saying that, teacher, so the M at here, should I using 20745? If you put at here, doesn't matter. After you round to two significant figure, you will get the same final answer. That is the reason why IGCSE final answer they make it two significant figure. Okay, so if you using the mass is in more accurate value 20745, put it in here, of course you will get 14 something. Okay, but after you round to two significant figure, you will get final, you will get the same answer as me. So it's fine whether we're using 21,000 or using 20,745. Is it okay? Can we go to page number 5? Okay, so next. So this is the tanker lorry full of liquid. Okay, inside got a lot of liquid. So that means that mass is higher lah. Mass is higher. The tanker deliver the liquid and drive away empty. So at the end it's become empty tank. Compare the acceleration of the empty tank. Okay, boys and girls, if empty tank mass decrease, what happened to your A? Empty tank. Okay, your full tank is mass higher. Higher mass, your acceleration actually should be what? The third box. Is it? Full tank will accelerate more. Mass higher, your trolley, you go to shopping mall, you push the trolley, inside got a lot of things. The rice, the whatever the things, do you able to accelerate it faster? More acceleration? Yes, Hui Tong correct. If your mass is more, yes, correct. If your mass is more, you are not easily to accelerate it. Okay, mass higher, acceleration actually will be less. So answer should be the first box. Explain your answer. Because full tank having a full tank larger mass. Larger mass. There's smaller acceleration. Larger mass. Or you want to say lower mass in empty tank, also no problem. Okay, can you do calculation for me? What is your acceleration? Here they're giving you weight, it's not mass, dear. So you have to think how you convert from weight to mass. Still remember the formula for this part? W equals to M what? Mg. So the net force that we use is Ma. You have to find out what is your mass. Is that clear? Find it out. What is your acceleration? Teacher, there is no G provided. You have to know the G. They won't tell you, but you have to know. G on Earth is 9.8. If today you are having the partial paper, which is before 2023, they were using the G as 10. But after 2023, actually it become 9.8. Okay, our new syllabus we're using 9.8. So this one is 50,000 equals to mg. So your m actually is, well, 50,000 divided by 9.8. 5102. Okay, 5102 kg. I put it here, 5102A. What is my resultant force? My resultant force is 6,000 minus 2,000. So 6,000 minus 2,000. I get 4,000 equals to 5102A. 4,000, just now I write wrongly. So 5102. 0.78. So A is 0.78 meter per second square. So this one, the front before the dot, front one, the zero is not counting. This one is called two significant figure. Answer is 0.78. Is that clear? If you didn't draw out, if you didn't draw out the picture, the diagram, so at the end you were confused. They got three force at here. What I should add and which part I should minus. Then you're confused and make the weight become part of your force. But no, the weight is pointing downward, is not affecting our horizontal motion. The horizontal motion is affecting by the 6,000 and the 2,000. The weight actually for us to count the mass. Is that clear, dear? We got the last question before we end our lesson. Is it okay? Megan say yes, Xuan yes, Crystal yes. Okay, then we proceed to the next page. Next page, last question. Okay, total mass. Total mass is this. Okay, 2.8. Constant force provided. This one is moving upward. What? So in moving upward, it will providing the upward force, which is called 3.2 times 10 power of 7 Newton. Okay, what is the total weight? Where is the direction of your weight? Direction of weight is due to the gravity. So weight will always pointing towards to the center of our earth. It will pointing downward, always pointing downward. So they give you the mass. They're asking you to calculate the weight. So W equals to mg. Okay, W equals to mg. So at here, we're using the mass 2.8 times 10 power of 6, 9.8. Okay, So let me count this one. 2.8. 2.8 times 10 power of 6 times 9.8. My answer is 27440000. Am I right? So as I told you, we make it two significant figures, so which is 1, 2. So I can write 2.7, 1, 2, 3, 4, 5, 6, 7. So times 10 power of 7 Newton. If you want to write 2, 7, then behind 60 also no problems, huh? No problems. Okay, so 2.7 times 10. Yes, Teresa, but we will make it into two significant figure or three, okay? So boys and girls, here we will 2.7 times 10 power of 7 Newton. Can you find the resultant force? You see, I already draw out. Can you find the resultant force? What is your resultant force? Using the big force minus the small force, resultant force. So for this one, okay, what is our resultant force? Resultant force will be 3.2 times 10 power of 7 minus 2.7 times 10 power of 7. So your answer, if you press your calculator, you should get 5.0 times 10 power of 6 Newton or 0.5 times 10 power of 7. Or you write how many zeros? 6 zero. Let me count, Teresa. 4, 6. Okay, correct. Newton, unit, don't forget unit. Okay, can you calculate vertical acceleration? It will accelerate in this direction. What is this acceleration? So net force is equals to ma. You already count the resultant force one. So we just use only. M, what is the mass? Okay, Teresa, yes, no problem. Okay, 5 times 10 power of 6. The mass for the whole 2.8 times 10 power of 6. Calculate your A. Press your calculator. If you press it correctly, okay, we will have the answer 1.8 meter per second square. Okay, 1.8 meter per second square. Is it okay? Normally what we did is horizontal. Today what we did for this question is vertical, but it's the same way. Okay, they say that, can you explain why acceleration increase? Okay, F net equals to ma. Why acceleration will increase? When it rises above the Earth's surface. Okay, so at here, we can think from in terms of few way. Why after that the acceleration will increase? Okay, we can think about the mass. If acceleration increase, that means that the mass actually what's going on. We were using the fuel, right? Full load of fuel. So after we using it, we run for certain times, the fuel will gone. Okay? So it will mass will decreases. This mass decreases. So imagine the trolley become empty. Of course you can accelerate what? So one of the reason we can say that is the mass of rocket decreases. Why decreases? As the fuel is used up. Okay, one of the reason why A decreases is because M decrease, A will increase. Second reason, you can think about the net force. Net force, if your acceleration increase, then one of the reason is because of your net force increase. One of the reason is because your net force increase. Net force is what? Net force is the forward force minus your weight. Okay, so just now we say the weight decrease what? So your net force also increases. This is one of the reason. No? Okay, another one is might be cause they accept that maybe your G W equals to mg. when you go up, further away, your G might be decreases, not 9.8 anymore. So at here, they also accept with the second answer, second way. You say that the value of gravitational value of G decreases. Okay, so at here, your net force actually is your force minus your weight, right? Weight is mg. If your g here is small g here small g, that means overall is small value. That means that your resultant will become higher. Resultant higher, then your acceleration will be increases. Or more easier to understand is the mass. Okay, mass. Mass decrease, so your object can be accelerate. Okay, then we're done for today's lesson. Any question? Any of you got any question want to ask me before we end our lesson today? If no question, can you give me reaction and then we will end our lesson right now? Okay, Xuan okay, Megan okay, Hui Tong leh? Okay, Crystal okay, Licious no, no is not okay. Licious no what? No question. Okay, no question.